I will start recording the session so we don't miss it. And we will start in a couple of minutes. Hello, everyone. We will be waiting a couple of more 2 minutes to let the people join, and then we will start. Okay, so let's start. Good morning, everyone, and welcome to today's workshop. My name is Maria Provecho. I'm from ETRA, and I'm the Dissemination and Communication Manager for the ECLIPSE project, and I will be the moderator for this session. We're delighted to have you all with us in this special event that is focused on how digitalization is driving Europe's energy transition. This workshop is co-organized by 4 European Union-funded projects that are ECLIPSE, BEGONIA, ODEON, and INSIEME. So there's a quick look at the agenda for today. We will have some introductory words. Then we will move on to different project presentations. Then we will have a slot for you to ask questions and make a panel discussion. And we will end with some conclusion and next steps. First, I would like to introduce you to Patricia Arsene, which is the policy officer at the European Commission in the DigiConnect department, and she will introduce a bit this session.
Thank you very much, Maria, and welcome everybody. Can you only confirm that you hear me?
Yes.
So I'm very pleased to be in this session, mostly because the projects which are around the table are telling a very beautiful story in the view of the Commission and how we see the digitalization of energy. For sure, this is something not new to all of you because you are all experts. We are talking about the digitalization of energy from many years now, and there were quite some policy actions which were tabled in different parts of the DG Commission in order to support this digital transformation. Only to mention some of them, and in fact, many of the work you are doing in the projects you are representing today, and that some of you are also coordinating, are stemming from these policy actions. You might recall the digitalization of energy action plan that the Commission adopted in 2022, and then the different legal acts that like the Data Act, the Artificial Intelligence Acts, which also came to support and to double the impact that we aim to achieve with the digitalization of energy action plan. And then there are several actions which are now under preparation and which are going to be soon tabled in this autumn. The Apply AI strategy, which will have a dedicated chapter for energy, the data union, which I will invite you to look at it when it will come, because there will be important provisions for the energy sector, which will impact your work. And then what will come next year, and this is the work of our colleagues in DGNR, with whom for sure we cooperate very, very closely, is the strategic roadmap for digitalization and AI, which is planned for the beginning of 2026. But all these actions for sure are inspired by you, by the innovators, because you are all innovators, and also by the innovations that are informing us you are working on. And just to say that what we have today, we have a nice link between the innovation actions, all then the funding of infrastructure, and this I'm looking a bit at the Begonia project for sure, and then the deployment. And this for us, it is something extremely important, because until some years ago, we were having the Commission was mostly supporting research. Then for sure, the innovation component came. But then we realized that you still need support in order to be able to transpose everything into reality. And this is how the Digital Europe program came, and we are happy to see that there are projects who are bringing the innovation ideas close to the market, and I'm very much looking forward to hear the presentations today. And then that we still need investment in infrastructure. We need digital infrastructure because this will support the digitalization of energy, and we need cross-border infrastructure because this is, let's say, the weak link that we identified based on information received from you, then it is still needed. So what it is our, let's say, dream, because even if we do not give this feeling all the time, we are still dreaming, and you are helping us to dream. We dream that with your support and by seeing the results of your projects implementing soon, we are going to have a fully digitalized and also AI driven, because the AI is coming, and one of the projects is implementing also solutions, AI solutions, and we are going to hear about it. A decentralized energy system, which is integrating the renewable energy sources, the intelligent storage and the smart buildings, and also the electric vehicles, because everything is more and more complex. So with this, I'm looking forward to listening to you. I'm sure that all your work is extremely inspiring. And I thank you to Lola and to the ETRA team for initiating this meeting today, this workshop.
Okay, thank you so much. So now let me introduce you to our speakers today. We have Moises Anton from ETRA representing the ODEON Project. Moises is an industrial engineer specialized in energy technologies. He has a solid experience in managing R&D projects in the field of energy efficiency, working within European Union frameworks like Horizon Europe and Horizon 2020. His work covers both technical and economic aspects, from proposal preparation to full project implementation. Then we have Nicolo Fatiroli from Olivo Energy that is representing Begonia Project today. Nicolo is the Chief Operating Officer at Olivo Energy. With a background in energy engineering, he brings deep knowledge of the European and Spanish energy markets. His expertise spans electricity market regulation, flexibility, energy communities, and e-mobility. He oversees internal operations and the successful delivery of consulting and innovation projects. Then we have Lola Lacreu, also from ETRA, and representative of ECLIPSE Project. Lola holds a degree in industrial engineering from the Polytechnic University of Valencia and from the University of Manchester. Since 2008, she has worked as senior project manager at ETRA, leading proposals preparation and coordinating European collaborative research projects in the field of smart grids and energy systems, such as XFlex, Eclipse, and Novel Grid. And finally, we have Johannes Vollmer from REF, that is representing the INSIEME Project. Johannes has over 13 years of experience in green energy and climate action. His background includes European Union policy, funding programs, and strategic business development to support climate neutral transition. He works to advance Green Deal goals, especially in digitalisation, renewables, and stakeholders engagements. So with our speakers introduced, I will give the floor to Lola that would introduce the 4 different projects, and then we will start with each project presentation.
Thank you very much, Maria, for this. Thank you very much also to Patricia for the introduction. Thank you for the speakers that took the invitation to be here, and also all the people that is attending this workshop, which I hope it is interesting and useful for you. As already introduced by Patricia, we decided to organize this workshop, first of all, because, based on ECLIPSE solutions, we start getting the first results. We also identified other projects that were also interesting to participate and to present their results, but not in a selected way, not in creating silos. But the idea was to, as it's included in the title, to show you one vision based on 4 different projects, all of them with the same objective to promote the digital transformation of the European energy system. So before we are going to the details from the different partners of the 4 projects, I wanted just to show you the general ideas of this project and also to show you which are the link. I mean, as you can see, ODEON, ECLIPSE, BEGONIA, and INSIEME are all of them are interrelated projects, all of them European projects from different programs. And with all of them addressing different levels of the energy ecosystem, European ecosystem, also depending on different degrees of technology, maturity, etc. For instance, ODEON, it's a Horizon Europe Innovation Action, which the focus is on acquisition of end devices data and also federated spaces. It started 1 year and a half before. So Moises will present us the first results. We have, on the other hand, also starting 1 year and a half before BEGONIA Project. In this case, this is also an Horizon Europe project, but it's an CSA, which in this case is focused on promoting the digital transformation but not only in energy, but also the transportation sector across Europe. And in this case, it's very promoting, fostering the cross-border cooperation, which is also very relevant, as Patricia mentioned. Based on this, and with some of the partners from these 2 projects, ECLIPSE Project, in this case, a Digital Europe project, also introduced by Patricia. It's it's a different program. It's not Horizon Europe. In this case, it's even going beyond research and more focused on bringing to the market the solutions. In this case, ECLIPSE, also coordinated by ETRA, as in the case of ODEON, is more focused on a specific common European reference framework in this case, to promote the energy consumption applications across Europe, promoting common platform, common architecture, based on standards and open sources in order to facilitate all different type of stakeholders in order to control and monitor the energy consumption. And finally, it's worthy to mention, and ECLIPSE started in September 2024, so it's almost 1 year and a half, or 1 year ago. This is a very specific situation because ECLIPSE is only 2 years, mainly because of the, as mentioned before, right, the Digital Europe program, which is very focused on going to the market. So the idea is to go very to the point and to provide the final solutions, and we will see later, the sooner the better. And finally, we have INSIEME Project, which is focused on, it's also a Digital Europe project program, which is focused on more broader common European data spaces, integrating results from different projects. For instance, ODEON, for instance, ECLIPSE, also BEGONIA is related, but also other projects which is not included in this session because, I mean, we had to limited timing. For instance, synergies, etc. It started only 3 months ago. Now is the time to present the objectives, but as mentioned before, it's integrating different solutions from other projects, also others that are not in the meeting today, such as ERI or synergies, and yeah, we will see the details later on. So after this, just to mention that now we are going to start with the presentations from the speakers, starting with ODEON. And as mentioned by Maria, after this we will have some time for questions and answers. You can you have Maria. We will present it better than me, but you have an option with questions and answers in the close to the chat in order to include your questions. And then after the 4 projects presentation, we will have some time for answering it, and also for some time for panel discussion. So yes, you are welcome to comment or to ask whenever you may need. Many thanks.
Thank you, Lola. So now let's start with the project presentations. We will start with ODEON. So Moises, the floor is yours.
Thank you, Maria, and thank you for organizing this session. I hope it can be a really fruitful session in which we can, let's say, share all these differences, but also common aspects within these 4 really interesting projects. So, well, although I have been already presented, just to mention that, my name is Moises Anton. I work as a project manager here in ETRA as well, and I am the project coordinator of the ODEON project. So, just a few words about the project is that ODEON is born out of this, let's say, European Commission demand to support the green and digital transformation of the energy ecosystem. So let's say there are a set of different challenges regarding the digital and green transformation, since we need to apply all these technical solutions at the same time that we enhance the resilience of the grid, and also we are aware that we can, let's say, integrate all these IoT devices that may reside on the edge of the grid, which are quite also an important aspect on the flexibility management, but also the digitalization aspects of the grid. So ODEON is born out of this, let's say, demand, this need for that has been identified. We will give further details about the. No, sorry. Okay. So yeah, just a few words about the ODEON project. We are a large consortium. We are 35 partners from 13 different member states. So we are testing our solutions in 5 pilot sites that we will give also some more details about the specificities of these demonstration sites. And our project is expected to last 14 months. It started on January 2024. Now we are 18 months after the starting of the project, so we are actually closing our first period in which we have actually worked on some of the technical developments that I would be mentioning afterwards in the presentation, but also with, let's say, a strong definition of which are the demonstration sites that we are expecting to be using as, let's say, starting point of real-time demonstration for our solutions, because our goal is that we can set a precedence with our solutions to be tested and to be an option for the real uh, live market. So I would move to the next slide. This is just an overview of all these different companies that conform the ODEON consortium. And just to go to much more detail about the technical aspects, let's say that the main challenge, as was highlighted before of ODEON, is to, let's say, have an impact on the challenges that the green and digital transition propose. For that purpose, ODEON strongly plays an effort and a role of these technical challenges that are associated to the digitalization and the green transformation of the energy system, since, as you know, there is quite a strong challenge with the integration of the different renewable energy systems, integration, and also managing the, let's say, flexibility, especially at the edge of the electricity grids. So for that purpose, ODEON gives a response by the development of an integration of the different aspects, meshing all this data, which is quite a strong important point for the ODEON project, intelligence services and market flows, so that we can propose a solid solution that targets all these technological, let's say, goals. Some of these goals and how we are giving a response to this is that we in ODEON we will send much more details about it in the upcoming slides, is to promote a highly distributed open framework that can orchestrate all this data and sharing all these, let's say, intelligence tools that can process and optimize this data coming from all the grid and electricity grid aspects. In that way, we can use this data to develop innovative energy services, enhancing two of the main aspects and two of the main, let's say, targets of the electricity grid, such as the grid resilience and the decentralized flexibility. By this means and by organizing this, let's say, focus on this central data gathering solution, is that we want to encourage that all these data and changes can be performed both from a technical and a semantic interoperability aspect, so that all this data can be easily read and easily exchanged by all the partners in the electricity grid. In that way, that we can promote a decentralized environment in this energy field, so that we can consider not only from distribution aspects, but also from the consumption and the local energy communities participation as well, the grid and electricity field aspects. So yes.
Oh, is it?
I don't know. Maybe he has some problems with the connections.
Sorry for this.
Yeah. Oops.
No, no, it's
Yeah,
fine,
you're
Moses.
back. Yeah,
Okay,
okay.
sorry. I don't know where did you lose me, but
I
No,
think in
yeah,
the next slide, no?
yeah, I think
Can
that
we
you
move
were.
in the next to the
okay,
next one, no?
probably sorry. My colleague had told me that he cannot hear me, so I let's
Yeah,
resume with this. So yeah, bear in mind that the technical challenges that the ODEON well, and overall the green and digital transformation proposes. Let's say that in ODEON we do not stick just to solving these technical challenges, but also we give the opportunity and we give like the space in the project. And it has been highlighted by Patricia the importance to give this solution a market, let's say, scape as well. So in the ODEON project, we are considering also all these business innovation and market uptake goals, in which taking into consideration all these, let's say, demonstration in our 5 large-scale demonstration, how we can reply, how we can give as an example of our project results tested in these 5 large-scale demonstration, a real solution for the rest of actors involved, and that would be kind of also be willing to digitalize their, let's say, businesses and have this data as the central and raw material for the project. So in other one, we also take into consideration these aspects. So, well, this is a slide about which is the main focus on the ODEON project, which is our cloud edge data and intelligence service platform, in which all this data coming from, let's say, the different energy stakeholders fields coming from different distributed sources um, is gathered, but not only gathered, but also processed, optimized, and secured in the different layers that we are proposing in the ODEON project, so that we also can consider cybersecurity aspects, but also the optimization through different artificial intelligence analytics, so that we are aware that all this data coming from different sources may be resulting in a large volume of data. So that's why we have this service, so that we can optimize all this data coming from the different distributed, so that um, we can process it and optimize it in a much more efficient way. So we are also giving the opportunity throughout this platform to connect as well through other connectors, taking into consideration data spaces and different federated data spaces as well, so that we can have this centralized platform as the, let's say, central core of the raw material for our project, that is data. So can you hear me? Okay.
yes, yes.
Okay. Okay, because I was trying to move the slide. Okay. So which is the goal of having all this data? That we are feeding it into different energy services that we are developing in the ODEON project, which let's say that we are not only focusing these tools from the point of view of the grid distributions, electricity distribution, that's to say distributed system operators, but we are also focusing, as the scope of the ODEON project is to, let's say, consider all these energy stakeholders in the electricity field, to also develop some tools for prosumers, but also some tools regarding local energy communities in the form of aggregator as well, which sometimes they lack of this, let's say, much more digital, let's say, transition that is expected, since they are not that let's say big or have these capabilities, but we are testing this, let's say, solution also on the behalf of these local energy communities. So we are developing several tools that actually will be as part of as part of the optimization and flexibility aspects and flexibility management, as was highlighted as some of the main critical aspects regarding the digital transformation and the green transition in the energy field. So in this table, we are setting all these different innovations that we are promoting from our side of ODEON. So the central core, as I mentioned before, is this cloud edge data and intelligence service platform that will be the central core of the data gathering. But we are giving a response to through energy services through, let's say, three main, let's say, group of energy stakeholders, some solutions so that they can let's say, optimize throughout the use of data, the energy flexibility and the energy optimization. That's why we have energy service for local energy communities and aggregators, energy services for prosumers, but also energy service for distributed system operators. And let's also remark that ODEON also relies on artificial intelligence artifacts that are being developed in the core of the different energy services that would be developed in the project. But let's say that we will give also the chance through the Cloud Edge Data and Intelligence Service platform to have availability of these artifacts that we are developing, because we are developing them in a sense that they can be reusable, readaptable, and available in our platform. So let's move through the different demonstration sites, because as I advanced at the beginning, the solutions that we are being tested in terms of having replicable sites are, let's say, focused on these 5 demonstration sites that, in overall, we have to bear in mind that we want to take these solutions to demonstration sites that are not, let's say, big, that have their characteristics, because that is a challenge that it can be proposed to some of these small or local energy communities, or let's say much more prosumers that are not that, let's say, aware with all these challenges with digitalization. So in overall, our solutions are targeted to these demonstration cases that, in the case of Montreal, are rural areas with some prosumers that, well, we have been checking during these first 18 months that they have this willing to learn from our solutions, that they have this willing to be digitalized and to gather all these solutions so that they can facilitate their operations. But yes, that also at the same time proposes some challenges, because they are not the most ideal, let's say, cases. But we count that both 5 of these demonstration cases have this willing and this, let's say, they are being testing this opportunity with the ODEON project, so that it can be, let's say, a replication case for the upcoming, let's say, interested partners throughout all this Europe that may have an interest in our solutions. So that's all regarding the ODEON project. So thank you for listening to me.
Thank you, Moises. So now is the time for Begonia Project. So, Nicolo.
Yes, and thank you very much for everyone also for organizing this event. And we are really, really happy to be here also because of the nature of Begonia and because of what we are doing. Our synergies with other sister projects are essential, and you will see the moment that I'm going to have the chance to explain a little bit what is Begonia, who are we, and what are we doing, because we are a slightly different kind of project compared to others. And I'm going to have to ask you to pass the slides quite quickly, Maria. I'm really sorry about this. But anyway, yes. So in general terms, we are actually we are not a Horizon project. We are funded by HADEA, but we are working essentially for DigiConnect. And what we have been tasked to do is more of a preparatory action. So we don't have demos. We are not testing anything directly, not yet, actually. But we are very much a preparatory action for what is going to come after. So this is the reason why we say that we're trying to drive the digital transformation, and we hope that our results not only will turn into something that will be implemented afterwards, but can also feed useful information to some sister projects as the one that we have here today. So you can pass slide, and again, okay, so yeah. In general terms, as I was mentioning before, we are funded by HADEA, but we are under the CEF, the Connecting Europe Facility. And so we have one main focus in everything that we're doing, which is to study the best use cases around in Europe of what are called operational digital platforms. And we're going to see in a second what is that we mean by that. And our idea, again, the idea of the project itself is to be a support action. So we were tasked to prepare what it will be in a little while, an implementation of the operational digital platform that we have developed in Begonia. Okay, so this is a slightly different type of project. But of course, our results, as I was mentioned before, can be quite useful, both for the implementation that is going to come after Begonia, but also for other sister projects that can take some ideas that we have developed in our action that can be taken in other innovation projects. Okay, so really quickly about the consortium. In our case, we are a very small consortium. We are only seven entities, let's say, among very different countries. And our project, we started in January 2024, and this was supposed to be 2.5 years. Quite likely, this is going to be a 3 years project because, of course, I mean, the work is always way more than you anticipate. Because we, as Begonia, as I was mentioning, we are doing like a preparatory work that is going to lead to a call for works from DigiConnect and HADEA. And in our last 6 months of the project, we're going to overlap with the first 6 months of the consortium that is going to win this tender. So clearly, we are very much dependent on when this project is going to start, and we are going to, our last efforts as a project will be to give support and knowledge transfer to the winning consortium. Okay, so this we have already slightly covered it, but I think it's very important to stress it. So the idea of the project was to look around Europe, try to understand what were the best practices of operational digital platforms, or the use cases that we thought that could turn into interesting operational digital platforms, both in the energy and transport sectors. And this is very important. We are usually like in a little energy bubble, and I'm especially talking for myself about this. But of course, this was not our only focus, which was very challenging at the beginning because, of course, energy and transport. When we talk about electric vehicles, it's quite obvious that they are together. But transport means so many more things than that. So, of course, we had to start from a really wide scope, let's say. Once we did it, we had to do like some feasibility studies and some developments of these use cases that we identified to try to understand. To try to develop them, right? So we started from concepts, but we had also to filter them and to develop them, to turn them into something different that was implementable somehow. And that was brought us to our third point, let's say, because we had to try to prepare this concept for deployment. So this is not about innovation. This is not about research. It's about implementation. So we had to try as much as possible to prepare some concepts that were almost ready to be implemented, right? And finally, our final and probably most important task was to give feedback to the Commission and to HADEA for the preparation for the new call for works for the implementation of these use cases. Yeah, so in order to do so, you can pass the slide, thank you. In order to do so, we had like very different phases, but before we present them, it's quite important to explain what is that we mean by an operational digital platform, right? Because there is no official definition per se. And for us, after many discussions, this is a digital ecosystem, a complex digital ecosystem that is integrating together both the hardware and the software to facilitate both the flow, the storage, the analysis, the processing of the data, and they can provide multiple services by multiple stakeholders at the same time, right? So it's kind of like a federation of stakeholders and services that can provide benefits and services to stakeholders in different sectors and in different countries at the same time. And the point is that in principle, they should build and connect on existing providers' platforms and new and emerging European data infrastructures, okay? And the features, the main features that an ODP, as we call it, operational digital platform, should have are the ones that you can see here. So that, of course, the monetization, the possibility to access and use data across sector, the possibility to scale it up very easily, to be automated in many of its features, to try to lower the investments, of course, and again the hardware part, right? So to have like the sensor network and to have some KPIs that can be monitored at all times. So again, it's a very complex concept that doesn't have like a unique definition, let's say. But I think that with the description of the use cases, you're going to have like a way better picture later on. So yeah, in order to do our job, we divided our project in 3 stages. I will guide you through them very quickly because, of course, I mean, it's interesting to understand how did we work, but the most important thing is where did we arrive, right? So we started with an exploratory study. So we tried to collect use cases of data spaces related to energy and transport all around Europe, and we tried to evaluate the most interesting ones. Then we had a second phase in which we basically tried to filter them as much as possible and develop them. So from all the ones that we identified in phase 1, we had to come down to 6, only 6, that we also had to develop. So it was not only about filtering them, but to arrive to 6 and then to start developing them. So starting from the use case that it was given to us by some stakeholders, we had to create something new, more complex, an ODP, again, an operation digital platform. And then the very last stage was to decide which of these 6 should go in the call for works of the Commission, or that we should propose to the Commission to be included in the call for works. And for this, we had to go down from 6 to 3, okay? This is the third stage of the project. We are in this stage. We have already sent our recommendations. And within the third stage, we're also going to do a little bit of testing, but this is all. Then the final part of the project will be the overlap with the winning consortium that I was mentioning before, and all the support that we're going to give to facilitate the first few months of the implementation. So yeah, here we're gonna go quite quickly. So yeah, at the very beginning, we identified eventually 14 different use cases that were very different from one another. Again, very wide scope. So we had some that were way more energy related, about grids and demand side flexibility, other that were related to completely to transport and linear infrastructures. Many were related to ports that are critical infrastructures, extremely cross-border for obvious reasons. So they were very diverse, but all really, really interesting. And it was not actually an easy task. And if you can pass the slide, we actually have, if you can, okay, thank you. We have a heat map, and we try to understand and to map where these use cases were, right? So we had many that were more energy related. You can see them on the center left, right? And kind of all of them were cross-border because this was one of the main asks at the beginning of the project, right? And then we had like a cluster that's of more transport or mobility related use cases, and some of them, they are labeled also as outermost, right? Because they are the ones related to ports. So they were not even just cross-border, they were something else and something more. And the very first thing that we tried to do, because it was a very difficult task, of course, to come from these 14 to the 6, was to merge a few of them. We saw some synergies. We saw that some use cases were interesting enough that we needed to keep them. So we tried to merge them, and this is what we did. And this is the reason why, yeah, we managed to merge them a few and filter others, also relying on some external stakeholders and their feedback. And yeah, and then in stage 2, we managed to shortlist 6 that we can see now. Yeah, so these were the 6 use cases, and the reason why we are presenting them, there's 2 separate slides. So in the other one, there are other 3, but the reason why we are presenting them is that, as I told you, then we had to decide to keep only 3, but the ones that were excluded are really, really interesting. So, and we, of course, we also had developed them. So we have some publications, and I encourage everyone that is interesting to learn more about the use cases, even the ones that were excluded, to take a look at them, because these are really, really useful concepts that are already almost ready for implementation, that there are some stakeholders that are already working on them. And it was a very hard decision for us, but this was our mandate. We had to do it. So the 6 use cases were one, we call it electricity customer-centric operation digital platform, because it's very much focused on final consumer services for final consumer, expanding from organization of energy communities, demand-side flexibility provision to the grid, automated supply switching. The second one, use case 2, is a platform that is very much focused to cross-border use of electric vehicles and electric trucks, both from the charge point booking and dynamic pricing and again flexibility provision, but also to the routing of electric trucks. So that has like a double nature. The third one is very much focused on data centers and all the services that data centers can provide, and to try to maximize their energy efficiency. And then, if you can pass the slide, we have the other 3. There are more transport related, as you can see. So one was a use case focused on streamlining, let's say, the drone permit process for inspection of linear infrastructures, especially cross-border. This is a big issue that this platform can solve. And then there are 2 that are very focused on ports. One is about smart ports operation, so using new technologies and digital tools to organize all the operation in large ports. And the final one is a platform that can support the calculation of the carbon footprints of goods, especially and giving suggestions for routing and port organization logistics. So as you can see, very, very different use cases, and it was extremely complicated to select them, but this is what we had to do. So we used, for the selection process for stage 3, cost-benefit analysis, technical feasibility, regulatory readiness, and the stakeholder interest, which for us was absolutely key to try to understand where the stakeholders were more interested. And if you can pass the slide, these were actually the 3 final ones that we identified as the most promising one that we recommended, right? So the first 3 that are actually more energy related. And thank you very much. Yeah, because in fact, this can give me the chance to give you like a little taste of each one of them. So the electricity customer-centric ODP is, again, as I was mentioning before, really, really focused on final consumers. So it's a unique platform that can clearly work cross-border. So like in different countries, absolutely at the same time, where many different stakeholders can access and can offer services, even not only the consumers, but also the service providers, for automated supply switching, organization of virtual energy communities, procurement or of offers of demand-side flexibility to the grid, but also a recommender of grid vulnerability. So this is a more service for system operators that can understand and know more about their own grids. The use case 2 yeah, again, way more focused on e-mobility, right? But it can offer a bundle of different services, not just one. So first of all, it's like services even for retailers, because based on the need of electricity from electric vehicles and based on renewable generation, they offer suggestion for dynamic pricing to incentivize the consumption or then the connection to the grid of electric vehicles where there is more renewable energy, where there is like an abundance of generation, and to try to incentivize the consumption there instead of somewhere where maybe the grid is more congested, right? But also, of course, there is the part of the routing of electric trucks to try to make it more organized and better. The flexibility services for grid balancing where possible through the electric vehicles and trucks that are connected, and the booking system, of course, for the electric vehicles users. And finally, the one of the data centers, again, we know how data centers are important, and this operational digital platform can, again, as the other ones, offer multiple services at the same time. So first of all, to try to maximize the efficiency of the data center itself. So like a services for the data center owners directly, but also solutions to provide flexibility to the grid and also do what is called the computational workload shifting. So if there are two data centers in two different countries that belong to the same owner, it is possible to shift the load, the computational load from one to the other if the electricity prices are lower or if the grid is more stressed in one country or another. So again, very complex services that are all bundled into the same ODP. Okay, so the next steps, and here actually I have already mentioned them quite a lot, but in any case, we're going to do like some very simple testing on these use cases, and we're going to present them in a dedicated workshop that we're going to let everyone know when this is going to be, but of course, we're going to deep dive way more into these 3 use cases. And of course, which is the most important thing, we're going to support the World Consortium in the implementation process in its first 6 months. And these are our contacts. I hope that you will find this interesting, and I encourage you to follow all of our activities on our website and to participate in our workshop. Thank you very much.
Thank you very much, Nicolo. Now it's time for the ECLIPSE Digital Project.
Hi, thank you very much to all of you. So yeah, now it's time for ECLIPSE project. Please, next one, Maria. Yeah, first of all, why we identified the need of our ECLIPSE project, as I mentioned before, the Digital Europe program. We received the notification from the Commission that it seems, as probably all of you already know, that several energy apps information energy apps monitoring information from mainly for domestic consumers were existed around Europe from different stakeholders were the owners of these apps, mainly DSOs, TSOs, retailers, aggregators, even third parties using different flow platforms, different protocols, different standards, different type of data formats, etc. So what was identified that there were many of them, but with different type of there were not existing common standards. For instance, common data formats or even the access rights were very different between each other. So it was also it was hindering the development, also the deployment, and also the use of these energy apps, and also the existing ones, but also the new ones. So based on this, we identified a need of a project like ECLIPSE in order to develop a common European reference framework. What it is, at the end, is a set of guidelines, architecture, standards, format, interfaces, etc. In order to provide a standardized framework for energy saving applications across Europe. Then it will be possible to enable a consistent and interoperable solutions that will help on one hand to the consumers in order to reduce the energy consumptions, energy billing, even energy emissions, but also will help to operators in order to increase the flexibility to shift, to facilitate the shift of the energy usage depending on the grid conditions. So they will ensure that all these energy service saving applications were scalable, compatible, and effective all across the European member states. Next one, Maria. So what is ECLIPSE in a glance? It's a digital Euro program project, which is an energy consumption reduction framework based on open source reference framework coordinated by ETRA, with a consortium of 23 partners from 13 European countries. It's such a big project because it is very focused on demonstration and replication. As mentioned by Patricia, one of the main aim of the Digital Euro program is to go closer to the market. That's why the demonstration is so relevant in this project. So the research is not so relevant, but at the end is the deployment, the demonstration, and also the replication in order to going closer to the market. That's why we have 16 European countries involved in 12 pilot sites. The total budget of the project is almost 10 million euros. The funding is 5. As mentioned before, this is a very short project. It's 2 years. It started in September 2024 and finalizing in August 2026. Next one, Maria. So very quickly, just to give you an idea of the 23 partners, there is 8 research R&D entities, which include not only companies, but also universities and research institutes, 7 DSOs from 7 countries, 4 TSOs for different countries, 2 energy services providers, and 2 energy associations. Next one. Yeah, just very quickly to show you. Yeah, I'm not going to go to the details of the 23 partners, but just to mention that they are very relevant partners. Most of them working in European projects for many years ago, involving as you see many end users and but also research entities. For the time being, closing the first year, almost closing the first year of the project. As you can imagine, we have been working in the definition of use cases, technical requirements, but also on the design of the app. For the time being, we have co-create, and I say co-creation because it involves everyone, all the partners on the consortium to define the different use cases. That is very relevant because it's in that kind of projects, which the end user is, is the key, because we are going to provide the tools for end users. So technical partners by itself, they cannot do it. We do need the support and the active involvement of end users. I wanted to highlight this. We have identified 51 use cases. For the moment, we identify 6 categories. We are closing this deliverable. We will have the definitive version submitted to the Commission during this summer. For the moment, 6 categories: energy invoice reduction for consumers, which it means the optimization of the consumption in order to reduce the invoices, the bill of the final consumers. The second one must focus on the reduction of the carbon footprint based on the customer awareness. The idea is to provide the energy app with generic but also personalized messages in order to help the end users to reduce their consumption and environmental impact. To enhance the quality and the supply of the grid. As mentioned before, when you reduce your consumption or you move to consumption to other timing, you are not only helping consumers to reduce the billing, but also it provides more flexibility to the grid, which is needed for operators in order to, for instance, avoid the blackouts avoid problems on the grid on a specific timing when the consumption is higher. The 4 categories is optimization of customer energy flows. It proposes the optimization of the energy consumption based on IoT devices. It includes, for instance, energy sensors, including in different part of the devices, of the houses, etc. With this information, it is more easy for the consumer in order to reduce the consumption of the different parts of the house. Also, thanks to these energy apps, the participation and flexibility markets of the consumers is easy. So by means of the TSO and the DSO flexibility proposals, makes consumers to participate in an easy way on the flexibility markets, which provide benefits for both operators and energy consumers. And finally, a very specific category, which we identified very relevant for many of the operators, which is the smart charging for EVs. Thanks to this application, it's possible to manage the smart charging of electric vehicles by means of the applications, and helping at the same time to the state of the energy grid. Next one, Maria. And now I would want to give the floor to my colleagues, which are Diego Garcia first, and secondly to Alejandro Vicente, which will present the first technical results of the project. They are both technical experts from ETRA, which are involved in the technical side of the ECLIPSE project. Also mentioned to say that, of course, the work that is going to be presented is a cooperative work for different partners of the project, especially the architecture of ECLIPSE with the collaboration of ETRA, but it's led by Trialog, which is the technical leader of ECLIPSE. But my colleague Diego, and as I said, Alejandro later on, will present it. Thank you.
Thank you, Lola. Can you hear me? Okay. So I will provide just a glimpse of the current status of the definition and the development of the ECLIPSE project. First of all, we started with this high-level architecture, this preliminary architecture of the different elements involved that are below the energy apps across Europe. So we identified these initial layers where we had on top of all the energy apps. Then we identified different types of services, both energy services as such, or digital twins, or some supporting services. Then we have a layer of data spaces, also including data lakes, data sources, and connectors to access this data. And at the bottom of the architecture, we have the different physical assets that in the end are the ones that are providing the data in each of the cases. We analyzed from a technical point of view the different pilots in the project, and we identified for each of these categories 12 different energy apps, including an additional one that is being developed as part of ECLIPSE, and that we will provide some information afterwards. 35 different energy services in each of the pilots, depending on the functionalities of the use cases that are going to be implemented in each of them. 22 different data sources or data spaces, and 12 additional types of energy assets to be integrated. Next slide. Okay, so previous one. Okay, so based on this, mostly Trialog with the inputs of the rest of the partners of the consortium, started developing a preliminary architecture and formalizing it using the SGAM model. Here we have the current status of the architecture, even though it hasn't been completed yet, and some changes can be introduced before its submission in month 15 of the project. So during the fall, during the autumn of the year. But here we have the main identified components of this architecture. So I won't go fully into detail, but we have from the energy app, that is the interface that the end user is receiving, and where he or she gets all data from the whole architecture, to the central space, which should be the data space infrastructure, which in some instances is a data space as such, but in other cases involves different systems that take care of the management, the storage, and the compilation and serving of the data from the different elements in the pilot and in the architecture. We have also of course, the utilities management and DSO's management systems, the market operator, the different automated energy management systems, and the home energy management system with the different types of device that in the end are providing flexibility to the grid and to the necessities of the DSO. Next slide. So after the components were identified, an analysis was took place, both including the state of the art of the energy apps in Europe, and most in detail the specific pilots of the project. In this case, the goal was to identify the commonly used communication protocols for each of the interfaces among the components of the architecture. And here we have a summary of them. So we have from HTTP, MQTT, AMQP, Kafka for high-level data transferring and IoT, to different standards for energy systems, substation automatization, metering data, OCPP for interaction with electric vehicles, and so on. So here summarize the different most common standards for each of the data exchanges in the architecture. Next slide. Then we have an analysis of the functions in the architecture. So we have from the consumer applications to market interaction, to data catalogs, the data models and exchanges, to services, including from monitoring to forecasting, congestion balancing management, and energy management tools, analysis, digital twins, etc. In order to make this a bit circular, next slide, we have mapped these functions to the original preliminary architecture that we started with. And here we have this color coding with that more or less maps the identified functions in the formal architecture of the SERF to the different layers that we initially identified, and also that can be used to map the real components and services and elements in the pilots to this architecture, and thus identify the interfaces among them and the needs for implementation. And next slide. Related to this, and moving on to to the development and deployment from all the interfaces identified in the architecture. We highlight these three, which are all of them interfacing the central data space or data management infrastructure. And the idea for these three is to implement generic connectors that can be reused and can facilitate the implementation of the SERF in the different pilots. In this case, and also as part of the analysis of the architecture, three components from previous projects and results from other sources have been identified in order to facilitate this implementation and also to implement these interfaces. The first one is the interconnect generic adapter, which aims at achieving the semantic interoperability among different services. So starting with legacy components in each pilot, services and systems that have their own APIs and their own communication methods. Specific service adapters are implemented in order to map this to a common API interface, and then the generic adapter can be used in order to register these services and these connectors, and register as well the what is called knowledge interactions, which in the end represent pairs of asking and answering for data, or posting and reacting for data. This is then implemented as graph pattern triples, and using this connector, the semantic interoperability between different components that originally were decoupled can be easily implemented. This is expected to be used as part of ECLIPSE project in order to achieve this communication between components in the pilots. A second component identified as a foundation of the project is the ECLIPSE Foundation Modeling Framework, which mostly create digital twins models and the software for their integration. So mostly uses the semantic aspect meta model to create these submodels of the digital twins using RDF and Turtle syntax. And these models are then validated using rules, and the toolkit of the ESMF provides functionalities that automatically generate the APIs and the documentation for these digital twins, which in the end makes it easier and facilitates this implementation of these specific components and their integration into the SERF architecture. And next slide. Finally, the last interoperable connector identified is the EDI connector, or the EDI framework, which comes from the EDI project, which in the end is a data space and data sharing infrastructure that manages both validated historical data for regulated use and near real-time data for aggregators and flexibility purposes. It uses the 62325 standard for consent and permission management, and implements this semantic interoperability through the common information model. in order to create these connectors for the data. These regional connectors are implemented in order to integrate services from data access providers across Europe, and they have a set of providers in different countries around Europe already implemented, and this can be extended as part of the ECLIPSE project if needed for the implementation of the SERF. And next slide. Finally, and as this we don't have too much time, we wanted to also provide a quick glimpse of the ECLIPSE Energy app. Just as an introduction, this is not a definitive app that everyone needs to use. It's just an example on how a software developer or a software provider can implement an application and can use the SERF to take advantage of the architecture and the services in order to integrate the data from the different actors and the different systems in the architecture. In this case, I will leave the floor to my colleague Alejandro to provide this quick demo.
Thank you very much, Diego. Just one word before our colleague Alejandro will start with the presentation. Just to remark that the ECLIPSE is providing, as mentioned, the Common European Reference Framework as part of the project in all the 13 pilot sites. Some of them will implement they have their own energy app who will be adapted to our framework, but there are some others that normally small operators or small operators that doesn't have yet any type of monitoring application. So we are providing as part of the project, we have developed as part of the project, the new application, mainly for the partners that wanted to have a new application from scratch. So as you can imagine, this is the design and the development made for it as part of the ECLIPSE project is based of this of the Common European Framework. Just this. So please, Alejandro.
Yes, thank you, Lola, Diego. So just to end up with the technical presentation of ECLIPSE, let me share my screen and I will do a brief demo of the application and the functionalities that have been developed so far. Can you see my screen?
Yes.
Yes, so first of all, and before going into the application, as already said, but just to make it clear, this is an energy application that's been developing in the energy ECLIPSE project, and it serves basically two main purposes. So on the one hand, to showcase the results of the ECLIPSE project and also to the benefits of using the CRF architecture developed within the project. And on the other hand, to provide this application to the pilots that don't have their own so that they can test the outputs of the project. Nevertheless, it goes without saying that this application will also be available for all the partners that want to test it, even if they already have their own one. So first of all, here in the login section, I already have a user, so we don't need to go into detail with the creating account, but if we wanted to create a specific account, just we input some general data, the ID will be validated, and then an email will be sent to the user. If confirmed, then he will be able to log in without any problem. So let's log in with the already created account. I think it's the other way around. So just to mention that the application is an early stage version, and all the outcomes of the CRF architects are still not integrated within the application. but we wanted to share you what we have so far. So I will be sharing with you all the screens implemented. Also to let you know that the application is based on some already existing applications that we have been reviewing that are similar to our use cases, and also takes into account all the use cases for the partners that are using the application within the ECLIPSE project. So the four screens that can be accessed in the application are here in the navigation bar at the bottom. First of all, we have the home. I already added a supply point, but let's go through the process of adding a new one. So supply point here can mean many things, but for now it's meant to be smart meters. So we would add the name of the smart meter, the location, and the CUPS, which is an identifier number for all the smart meters, so that we can, after this registration of supply point, obtain all the available data for that smart meter. So we would add these three fields and then click on save. I'm not going to do this because we already have one. And then we would have our supply point register. Here we can view and edit the details, and we can add the appliances that are connected to that smart meter. I already added two of them. We can keep adding new ones. So for example, air conditioner, we can add the model, we can add a description, and also the type. The type will be important later on, as I will explain, because we have a already established set of appliances. This can be extended, of course, but for now, these are the appliances. So we can add an additional ones, click on add, and we will be adding that one. Then if we go back and go then to the next section, which is monitoring, we can see here different graphs for all the data that's been obtained for the smart meter. Here, just to mention that the application is meant to be generic. This means that all the different partners can access and use it, no matter if the end user is from a DSO, from a TSO. So in this sense, the application will be showing different notifications, different graphs, depending on the end user. In this case, I added some graphs that can be modified later on, but for now we have the consumption for the day, for the week, or for the month. We can see here all the consumptions retrieved from the smart meter. Then we also have a disaggregation graph. Here is when the appliances come in play, and are important because here we're using a service called NILM, aka non-intrusive load monitoring, which is a service developed by ETRA, which takes as input the total power consumption of a smart meter, and then disaggregates all that consumption into the different appliances that are connected to that smart meter. So in the end, the user is able to see throughout all the day which has been the consumption for the different appliances, and then decide, for example, if there's some appliance which has problems, if there's some other that is consuming too much, and so on. So here we can see all the appliances are registered and the consumption of every single one of them. And then we have electricity cost for the day, the week, the month. Again, this all comes from the energy retrieved from the smart meter. Then we have the flexibility section where we can modify some of the settings of our smart meter and from the application too. So for example, these are the notification thresholds, which means when will the application notify us if our smart meter has exceeded some of the consumptions for the day, for the week, or for the month. We can modify this, no problem. Then, for example, Then we can modify the contracted power, peak power of peak power. Again, as I, for example, took this section, I took inspiration on a Spanish application. Maybe it can be different for different pilots. So in the future, we will make sure this application can be suitable for all the pilots that are going to use it. And then we have a report section when, in case we have some issue with any appliance or the smart meter in general, billing, the contract. Well, we have here, before filling a report, some tips, recommendations in case we want to check, and if not, we can click on still not clear, and we can here add our ID number and the report details, and we will be sending here the report to our reviewer so that they can check what's the issue we have. And then finally, we have a tips section. This one is divided into general and personalized tips. General tips will be maybe the same for all the users, maybe different for TSOs, DSOs users, but in the end, they will be already established, no matter the user. But here in personalized tips, we will be using the information coming from the smart meter, the information coming from the disaggregated power, so that we can share with the user some tips to reduce the power consumption and then incentivize an improvement on the impact, and also reducing billing costs and so on. So as said, this is still an early stage version. These tips are not permanent. So we will be sharing the tool with the different partners and also accepting feedback, see which are the best tips and the most useful ones for the users. And we will be updating this on the way. And finally, here on the application bar at the top, we have the notifications menu, where we can see, after we have set our notification preferences, some tips on your specific appliance is consuming too much, or you should try and check this other appliance because it might be working poorly, and so on. Or this is your weekly energy summary. And last but not least, here is a profile menu where we can edit our user preferences, notifications, security, bank details, and so on. So yeah, this is more or less an overview of the whole application as it is right now. And yeah, we will keep working on it and keep you updated in case you are interested on how it progresses. So thank you.
Many thanks, Alejandro and Diego. Yeah, as mentioned, this is the preliminary version. The feedback, all the feedback is more than welcome. Also to apologize because we are a little bit on delay, but I think it was worthy to focus in this demo. Questions and answers for all the projects will be just after the INSIEME presentation. So yeah, many thanks. That's all regarding ECLIPSE project. Thank you very much.
Thank you. I will share again the presentation.
Maria, if you want, I can share mine.
Okay. Yeah, if you prefer. Okay.
But you
no
would
problem.
have to give me the rights to do so because they're actually unable now.
Yeah, sorry. You are supposed to be moderator also now. So
yes, thank you.
You're welcome.
Yeah, hi everyone. Can you see my screen now?
Yes.
Okay. Thanks for having me. I'm Johannes. I work with the European Renewable Energies Federation, which is a Brussels-based umbrella organization for national and renewable associations. We're mostly active in policy working, but we also do projects. One of which has recently started just in April now. Which is why I will not take as much time as the previous speakers, because simply because we haven't really produced any tangible results yet, and also I'm not a technician. I don't have a background in IT or in engineering, so you will have to bear with me on a much higher level with the project environment, history, and the keywords and the use cases that will be deployed across Europe. Maybe a few words first to the policy background. But Patricia already said a few things, but I think it's good to also put INSIEME into that context. It started with the European Strategy for Data that was launched in 2020 and had the objective to enable secure and trustworthy data sharing across sectors and countries in the EU. This is very much the basic of INSIEME. In 2021, there was the Gaia X initiative alongside other projects that is meant to establish a federated data infrastructure. We had then the announcement of the European Health Data Space in a different sector, but it was the first of its kind that came in 2022. Before there was the development and testing of data space building blocks with regard to standards, governments, and other tools that was supported through Digital Europe and the Horizon Europe program. You see here, I mean, there's probably a lot more in the ECLIPSE we just heard about. I mean, very impressive work also. I'm almost a bit jealous that I cannot share this kind of results yet from our side. Very important also is the EDI project, which is on establishing a distributed data infrastructure for energy. Also to mention EDA, which is the Austrian Energy Data Exchange, which was set up by DSOs, a decentralized data sharing model, which was, I think, also the first of its kind in Europe. And the reason I'm mentioning them is because the architects are also the technical coordinators and, let's say, the masterminds behind INSIEME. You have the maybe most relevant piece of communication was the digitalisation of the energy sector action plan that was launched by the Commission in 2022. There was the four main elements: data portability, interoperability, and governance, and the integration with other sectors. And the INSIEME vision is responding to those needs and challenges. And the idea is really that in the future we have EU member states that are seamlessly connected, not just by cables and pipelines, but through a secure, intelligent, and transparent flow of energy data. And this is the digital backbone, is the European data space for energy for our transition to net zero. We are still working on let's say, the communication and dissemination framework. We are, as RF, we are leading that work stream, and there will be a high-level description and a vision paper soon, which I'm happy to share. The initial elements of that vision, I mean, first, of course, citizens and consumers need to be empowered. They need real-time access to their energy data, to their energy consumption generation, but also to remuneration, ideally, for sharing electricity with their neighbors, with markets, within energy communities. This is very important, and I would be happy to also hear about ECLIPSE's perspective, how to engage with the citizens. I mean, this app is I think is brilliant, but in our experience, there was the challenge that people really stay on those apps for longer than, let's say, playing around with it for a week or two. But of course, if there is a financial incentive that is clearly visible, I think that would help a lot. The second part is, of course, the infrastructure. We'll come to that in a second. We have a lot of DSOs and TSOs and their representations in the consortium. of course, to balance supply and demand, to react to congestions, but also to cybersecurity threats, and to coordinate across borders, and to ideally bring, Europe's abundant renewable energy sources from one place to another, like wind in the north and sun in the south. This is a big objective in the vision of INSIEME. Obviously, this is the backbone of Europe's data economy, to have more jobs, more skills developed through innovation and growth, but also to enable startups, research institutes to leverage data, to access data they need for developing innovative solutions. I mean, this is already done in the other projects, obviously, and a lot of other initiatives. Trust and security. I mean, INSIEME is based on transparency, on European values, privacy, security, and this I think is very important to bring more people and energy stakeholders, actors to the table. That depends a bit on the countries. There's a different cultural context, as you know, when it comes to sharing personal data. But this is a pillar of INSIEME, and the cybersecurity aspects have been worked into the deployments and the design of the project from the very beginning. And I mean, to make it even more high level, it's a symbol for European unity. I think it goes beyond just to build a data architecture or infrastructure for Europe, but to really demonstrate that Europe is still a global leader in the transition to net zero, and that we can unite among these common goals. Yeah, maybe for just a step back, I mean, there is 14 data spaces that are foreseen for the sectors that you see here. This is ours is obviously the one for energy. I think there's a lot of parallel work and a lot of need also to coordinate among those who are in charge of establishing the other data spaces. This is a large part also of our communication work, or will be. And within the energy sector, I mean, of course, there's a huge need to also talk to the other initiatives, as we are sharing partners, we are sharing results, and we are building on what has been done before. Yeah, just in a nutshell, there's, this sounds a bit crazy, 54 partners that are in INSIEME. When we had our kickoff in Vienna in April, there was over 100 people, and that kind of made it very clear about the challenge to also to coordinate and govern the project, but also to communicate within and outside of the project. The budget is 16 million euros, 8 of which are coming from the Digital Europe program. And we have 7 use cases in 15 countries. They're being deployed in well, all over Europe almost. We'll come to that in a second. Yeah, here you can see a short look to the consortium. We are research and innovation institutes. In universities, there's infrastructure operators. We have, for instance, the DSO of France, with I think 40 million connected customers. We have industry associations like ourselves, but also ETSO, which is the European organization for larger DSOs. We have new market actors like aggregators. We have obviously consultants. We have other solution providers. I mean, there's really the whole value chain, I think, is represented in INSIEME. Here you can see the coverage. I mean, where INSIEME is going to be deployed in most of the EU countries. Maybe a few words on the use cases. For instance, energy efficiency and flexibility management. I say this is our 7 use cases, but we have 15 deployments. So these use cases are being deployed in different places. And for example, for the first one here on the slide, there is an application for that shows you the carbon footprint, and the idea is to have data hubs in Poland, Lithuania, and Estonia connected, and to have a common demand response service that can be deployed across these 3 countries. The second one on collective self-consumption, we have 20 new and established energy communities in the group. And the idea is to go beyond national context to scale up solutions that will, for instance, help communities to have members joining or leaving, to manage self-consumption, to share also the revenues, to access real-time data, and to help with settlement and other technical operations. This will be deployed in quite a few countries. Grid and flexibility services. This is, for instance, there's others, but for instance, there's the Rome Flex project, which is run by the DSO Areti in the city of Rome. Has been quite successful and already a big project, and we're going to build on that. And there's sources and assets that extend to 4,000 plus users. We have 50 prosumers and 50 charging stations for e-vehicles in there. And the idea is to upscale the digital flexibility marketplace that was built under Rome Flex, and to have small assets come in and benefit from local flexibility markets. The fourth one, electromobility, for instance, is a regulatory sandbox run by Vito Energy Ville in Flanders, here in Belgium. The idea here is to have, just have to go through some of the information here, to make use of 44 EV charging points, and to overcome challenges that are related to smart charging and flexibility service by integrating car apps, charging platforms, and the Energy Ville platform, which already exists. It's a living lab that can combine weather forecasts, energy markets, real-time measurements, and historical data. And this will be the deployment for electromobility in Belgium. On renewables integration, we have the TSO and DSO and other stakeholders in Denmark that will provide data and improve forecasting of district heating loads, but also in smaller cities where we do the same for a number of buildings that provide flexibility services for both electricity and heating grids. This is done mostly in Denmark, but is a solution that can be applied in many other countries. We have networks and integration planning. This is, for instance, a deployment that is led by the TSO in Portugal, that have obviously access to data across the country. We have smart sector integration as well, where we look at to integrate electricity and gas supplies and the data from both sides. This will be all communicated soon a bit more in detail. I mean, this is just a quick glimpse into the use cases of INSIEME. Well, I mean, this is an overview. I mean, we are probably quite familiar with this sort of diagrams where you see the different actors and you see the challenges that need to be overcome. It's highly complex, and it will also take an effort to communicate this to the outside world, maybe to an audience that is not as much as an expert audience as reunited today in the meeting. Very good, of course, also to enhance once again that the cooperation with the other projects is very important. Maybe a bit of also what has already been adopted in terms of legal and policy reform at EU level, which is a bit also our expertise and our involvement as RF and as communication dissemination lead. You know about the clean energy package and certain provisions that were agreed on 2018-19 Renewables Directive that was then amended, and all the different bits and pieces that came out of it. And one big package was the network codes. We're currently in the process, our experts of INSIEME are actively contributing to or have actively contributed to drafting the network code on demand response in the EU DSO entity together with NSOE. You can see a bit, maybe we can share the slides, of course, with the other participants, what that implies. And the last slide of the presentation is a bit to show how this is then implemented on the ground through INSIEME. The demand response network code is currently in the hands of the Commission, and is also connected to the Interoperability Implementing Act, or stemming from it. And there is the data for energy expert group in the Commission that has quite a few of INSIEME's experts in there. And INSIEME in this context functions as a reality check. We can go back to the deployments and say this is working and this is maybe not. And a sort of sanity gate that you can really say that this, which is the way forward. I think that is it from my side. I try to be a bit shorter also because, as I said, we don't really have results yet. We just started in April, and but I'm very, very happy to keep the dialogue open to the other projects and to look into good synergies that we can create. Thank you very much.
Thank you, Johannes. I'm coming back to the general slides. It's okay. Let's go. Okay. Okay, so thank you all for those insightful project presentations. It's clear that we are addressing this green and digital transition from very different and complementary angles. And now let's move on to our roundtable discussion. First, we will pose a specific question to each speaker, tailored to the project focus, and then we will open.
Yeah, but maybe it's better to start with the questions from the audience, if there is any.
If there's any question, the floor is yours. You have the chat or the questions and answers section. So feel free to leave your questions there.
Okay, since everything is clear.
Yeah, we can go through the specific questions, and if anyone in this time want to ask something, we will go back to this. Okay, so you can think about the questions in the meanwhile. So Moises, let's start with you. How does ODEON and its solutions help energy value chain partners to address the green and digital transition?
Yeah, well, the thing is that ODEON takes kind of a starting point that the green and digital transition relies, of course, on all these data sources as the raw materials that, let's say, allows these advances and evolution. So from our perspective and from what we have been seeing in the project, it's a true challenge, right, to establish this effectively all this data that comes from the energy sector, because we have to consider, right, this wide scope that the energy sector proposes, not only from the side of, let's say, grid management, but also the energy consumption. So in this way, we think that from the ODEON solution, we can create this interoperable and data gathering solution that can help into this crucial part, this, let's say, this milestone that presents the use of data and the gathering of this interconnected data. Because then if we have this part solved, well, as I explained during the presentation, this is quite of the critical most aspect. and the central aspect of ODEON. Let's say that we can have this data allow it to the rest of energy optimization modules to be using this data that at the same time can be considered decentralized and well at the end it's on a single, let's say, interconnected platform. So this is how we think that we can help let's say the whole energy value chain to address this green and digital transition throughout the adaptation of this platform, energy data platform.
Okay, thank you so much. Now over to Lola. How does ECLIPSE empower consumers and promote their active participation in the energy system? And in particular, how do you motivate users to engage with the energy monitoring applications based on the CRF?
Thank you, Maria. I think it's quite clear how ECLIPSE empowers consumers. By means of the energy apps, we are promoting the active participation of final consumers in the energy system. We give them access to real-time data by means of interoperable solutions based on CERF. However, as have been already mentioned by some of the colleagues, there are some barriers. The real challenge is to keep engaged the consumers along the time, not only maybe the first 2 weeks, I mentioned by Johannes, but to keep them involved. We have elaborated surveys for final consumers in this project. We have identified 3 main barriers. The first one is the difficulty to use and understand the energy apps. Some of them find it too complex. That's mainly for older people and with limited digital knowledge. So by means of CERF, we are trying to provide more intuitive, more visual, more easy to use applications. We are trying to co-create it with the feedback from our final consumers. And based on this, we also to organize workshops, tutorials, provide a manual for end users in order to facilitate the use of this energy per application and keep them engaged. On the other hand, also the lack of clear and tangible benefits, because at the end, if they don't find real benefits and not clear savings by the use of the apps, it's very difficult to keep them involved. So we are promoting the offering of real rewards, real economic incentives for active users by means of personalized alerts, personalized recommendations and tips in order to clearly communicate to them which are the real advantages of being part of this, of using these apps. And finally, there is also, having also identified a lack of confidence, a lack of trust from them, mainly in the side of data protection and because, as you know, to use these apps, we need real-time information from their energy usage patterns. So for them, for the final consumers, sometimes it's difficult to ensure that they are meeting the standards of data protection and privacy. So we are trying to let them know how we are going to control it, who is using this data and its way, in order to make it easier to them, to motivate them to keep using the energy apps.
Thank you, Lola. Nicolo, Begonia showcases several advanced digital solutions. Could you share some particularly innovative elements that highlight the project's forward-looking approach?
Yeah, and thank you very much again. I will try to be brief because I know that we're running out of time. So I will make a very specific example. I think that from now onwards, every time that we talk about data, we're going to talk about artificial intelligence as well, right? So of course, in all of our use cases, there are some AI applications. One quite interesting one is on the second use case, the one about electric vehicles and trucks, about the calculation of dynamic charging prices. Because picture this, so and this seems like far away in the future, but I promise you that this is already a problem that that in some countries they're facing. So people with electric vehicles that are moving, or electric trucks even, but especially with EVs, they're moving around different countries to go to work, right? And what happens that, of course, they prefer to charge their EV where in the country where the price of the electricity is lower. And this is creating already a lot of pressure on the grid where this is happening. So the idea, or one of the many services of the ODP, is to use AI to do a forecasting, right, for the electricity retailers, to do a forecasting of the renewable power generation, the grid loads, the traffic condition, and the charging demand. And with this information that is forecasted by the AI, you generate the dynamic pricing. This the idea then is to try to incentivize and encourage electric vehicles and trucks owners to charge during the periods, first of all, of high renewable generation, that usually they are coincident, they coincide with lower prices, right? And but at the same time to try to incentivize where there is lower grid stress. So if you see that in a country there are a lot of people that want to charge there, and this can turn into a lot of grid stress, of course you have in the neighboring country, and of course we are talking about people that move around the border. So this is just two towns or two charging points very close to each other, but in different points, to try to incentivize them to charge where there is lower grid stress, right? And this is like a very clear example. Another one is the one that I was mentioning before in the use case of data centers, right? So because here there are some AI algorithms that are trying to identify the flexible resources and the non-urgent processes of the data center itself, and supports the data center managers to move the computational load into another data center that they have. Of course, they have to be federated, otherwise this doesn't work. In order to, again, maybe reduce the grid stress, incentivize the use of renewable energy, and in this also saving money, because usually the moment that you move it, you're also paying a bit less the grid charges. So these are two very specific examples of two specific services of these two use cases, but of course the applications are many in many of all the use cases that we have selected.
Thank you, Nicolo. And finally, the question for Johannes. What's the most relevant recent or ongoing policy file that INSIEME can contribute to, based on your work and insights?
Well, there's a lot, I'd say. But maybe if we talk about consumer engagement, I mean, that was a headache since I think the clean energy package was started to being prepared, which was in 2014 and 13, I think. I think the EU did a very good job to provide consumers with provisions that should empower them. Problem, of course, is always the implementation in the member states. We are looking at that quite closely as an organization, and also through a number of European projects, and the implementation of projects such as ECLIPSE and INSIEME, of course, they are also designed to help and support the implementation of also regulatory frameworks in the member states. And I think this is a very important aspect of our work. And if you ask about specific provisions, I mean, there's quite a few of them in the Internal Electricity Market Directive that have not been properly transposed into the frameworks of member states, and we talk about the Renewable Energy Directives, and then all the legislation and secondary legislation is coming out from the digital side. We are in consultations on a number of files that are now being prepared also under the Clean Industrial Deal. And it is quite complex, and I think we have to also be very careful not to overload market and system actors with too much requirements, while the 2018-19 Clean Energy Package is not even properly implemented yet. So this is highly complex, and it touches on a lot of areas of regulation that goes into market design, but that is obviously all the issues around flexibility and the data exchange. Is hard to answer that question really in 2 or 3 minutes, but very good if also from the other projects we can share information that relates to implementation challenges and also the lack of political willingness or capacities in the ministries and regulatory authorities to go ahead and properly do their job, really.
Okay, thank you so much. Well, we are almost out of time, as we said the end of at 12. So we have prepared some common questions, but I think that we have more or less approached all of them. So we can go to the end of the session that consists on some conclusions and next steps from Patricia and also from Lola. So the floor is yours, Patricia.
I don't hear you, Patricia. I don't know if you're speaking.
Yeah,
Yes, now
yeah.
it's fine.
Can you hear me now?
Yes, but we don't
Sorry.
see you. At least me.
Yeah,
now
I
it's
can.
fine.
Yeah,
now
yeah,
it's
yeah.
fine.
Do you see me?
Yeah.
Okay. Thank you very much. Thank you very much for the presentations. I will be very short. I noted some takeaways and maybe also some kind invitation to all of you. First of all, it was a very reassuring session, because it is always good for us on the Commission side to see that we are still having innovators who are trying to integrate the sectors and to propose visions which are, let's say, vision of the present and of the near future. So what I took away, I noted a bit, is that, okay, you acknowledge, all of you, that synergies are essentials, that we need interoperability. Data orchestration is more than ever needed, but in order to be able to have that data orchestration, we have to have access to data. And we are seeing, and this is still said, at least in the Commission, looking from the digital side of the process, it is sad to see that there are still entities and mostly network operators who are a bit reluctant to share their data, and we hope to see this improving. We see that the artificial intelligence is something that we cannot contest. It is there. It is coming to stay, and this means that all the processes are accelerating, and we have to be prepared to embrace it. Also, the boundaries, so all the national frontiers are, let's say, from the technological point of view, no longer so much visible, because all the solutions that you are working on and all the solutions that are needed, in fact, are transcending all these national boundaries. And we acknowledge here what Begonia did with the operational digital platforms, and we are very much looking forward to see the implementation. This for sure will be very much supported by the other projects, and turning to ECLIPSE, enrolling more and more and convincing the consumers on the added value of using these applications, and on feeding their experiences and their trust also to the grid and to the network operators. Now, only a bit turning to the last two projects presented to INSIEME. For sure, we are, I think, the eyes of many people, and for sure the Commission are on INSIEME, because the energy data space, it's an essential component of the digitalization of energy. And there are many nice things that happened. There are many nice things that are there. And in fact, not only Johannes, but all the speakers mentioned what is there. It will be very good that before hearing about barriers, we hear about what it is there. There are many national or local or solutions implemented. So it is good to build on them. And having examples of something that is already done will convince the others, either network operators, either the developers, in order to accept that small steps have been done. And then it is the moment when probably the system slowly will accept them. I'm coming from Vienna from the D4E Data for Energy subgroup meeting. And it was enlightening to see what is happening in Austria, for instance, with already the data space that is there, which was not called data space when it was put forward more than 10 years ago, the first time. It was a data hub. Now it is a data space, but it's the same. It is this concept. So we also count on you at the Commission level. We count on the associations and we count on the member states to bring forward what all these innovators are proposing, because they are bright minds, but they need also the policy level that trusts them and brings all these solutions together. So this is also your role, and it is also the role of associations like the association Johannes is representing, that we count on your support in order to ensure that everybody is finding a common denominator, because in the end everything is about data. Even if it's the energy system, is data interoperability, crossing the boundaries and letting innovation to progress.
Many thanks, Patricia. I think it has been already all said by means of the speakers. Also to Patricia, just to close, a few words. All of us has insisted about the importance of interoperability between different infrastructures, standards, etc., in order to facilitate all the stakeholders, not only operators, aggregators, and consumers, but also even the developers and vendors, in order to foster the competition and scalability. And I wanted to highlight the cost effectiveness and business models. It's also important to demonstrate, to focus on the viable business models, on viable real economic benefits. As mentioned before, for consumers, it doesn't make sense to start to keep using an application that is used. It should be used for the reduction of the energy bill, if at the end you are spending hours of your time and the reduction is €1 per month or something like this. This should be also replicate for other type of stakeholders. It's important to identify who should be the most effective business models in order to work on this, in order to motivate all the users, not only in the sense of economic benefits, but also service benefits, environmental benefits. I mean, not only, or for instance, avoid the consumption congestions, improve the comfort of the consumers, etc. But it's something that should be shown, should be easily to identify and direct benefits to them. By means of these all complementary projects, we keep working in the digitalization and energy systems. We are keep working on providing benefits for all the stakeholders, and also to identify which are the current barriers, which are the existing solutions, existing infrastructure, in order to based on this, not to start inventing the wheel one more time, but working based on existing solutions, on existing research. That's why we think very interesting that kind of workshops with complementary projects, in order to discuss and to identify what is going on and what could be used from other projects in order to generate even more benefits. And I invite all the projects or new projects as well to keep collaborating, to keep organizing that kind of workshops and other events. also to Patricia and to other European Commission members in order to facilitate it. Of course, to thank all to them to be here. And I'm very happy, and I will very happy to keep working with all of you. So thank you to all the speakers. Thank you to Patricia, and thank you to Maria, of course, that we have facilitated all the presentations and all the chats. We are a little bit late, but I think it has been worthy. And Maria, if you want to say a few words, or any other other speakers as well.
Yeah, I don't know if some speakers want to say something. If not, just thank you all once again to the speakers for the participation, for the presentation and the discussion, and to everyone who joined us today. And well, I hope that we can stay connected. The audience, feel free to reach any of us if you have questions, if you want to get updates on the developments or innovations of the projects, and hope to see you again in future workshops or events. Thank you so much.
Thank you very much.
Thank you. Keep in touch.
Thank you very much.
Bye.
Bye-bye.
Thank you.